This is the third video for section 1.8 on bin packing and scheduling. In this lecture, I'll be talking about sorted weight algorithms. So to remind you, what we're talking about is what we call the bin packing problem. And in this problem, we have a list of numbers, which we call weights, and these numbers represent objects of various sizes that need to be packed into bins that have a particular capacity. The capacity is a number that tells you the total amount of weight that each bin can hold. And the goal is to pack the weights into the smallest number of bins possible. And we've already talked about a couple of algorithms for solving this problem, and in this video we're going to talk about a couple more. So in some applications, it's possible to look at the entire list of objects and then make our decisions for which objects go in which bins. So if we are in one of those situations, then what we want to do is pack the bigger items first, the heavier weights first, and pack the smaller items around them. So what our first step is going to be is to sort the list in decreasing order, from the biggest numbers to the smallest numbers. So that's going to give us two new algorithms. In the previous lecture, we talked about the first fit algorithm and the best fit algorithm. And so these are going to be variations on those algorithms. The first fit decreasing algorithm is going to be to first sort the list, like we talked about, and then use that first fit algorithm. The best fit decreasing algorithm will be to first sort the list and then use the best fit algorithm. So if you remember how to use the first fit and best fit algorithms from the previous lecture, this is just going to add a new step at the beginning. So this is the full first fit decreasing algorithm. We start by sorting the object in order from largest to smallest, and then work through our sorted list one object at a time, put each object in the first bin that has room for it, and then only start a new bin if none of the existing bins have room for the object. So let's see this in action. So this is the same problem that we worked on in the previous video, but this time we're going to use the first fit decreasing algorithm. So we've got our list of weights, and our first step, remember, is to look at the sorted list. So that's going to be the first thing I'm going to do. I'm going to write down my sorted list of weights. And here's a good way to sort a list of numbers like this. What I'm going to do is I'm going to look through my list of numbers and find the biggest number I can find. In that case, I've got a 7. I'm going to cross out that 7 and write it on my list. And the biggest number that's remaining is another 7, so I'm going to write that on my list. Now the biggest number remaining is a 6, so I'm going to write that down. The reason I'm crossing them out is so that I don't accidentally repeat a number, right? So when your lists of numbers get really long, it can be easy to lose track of what have I looked at yet, what haven't I looked at yet. So the crossing it out gives you a visual way to know that you're not repeating anything. I've got 2 5s, so those are going to go next to my list. I've got 3 4s, those will go next in my list. I'll cross all those out, right? 4 4 4. And then I've got a 3, that's the biggest number remaining. And then finally I've got a 2. All right, so now I've sorted my list. Now we're going to go back and do what we did in the previous video, the previous lecture talking about the first fit algorithm. I'm going to start with one empty bin, and as usual, we're going to be keeping track of how much capacity is remaining in that bin. In this case, that's 10. So remember that when we look at an item, we're going to put it in the first bin that can hold it. In this case, there's only one bin. It can hold my first 7 weight, so I'm going to put it in there. And again, I'm crossing out the weights on my list so that I don't accidentally repeat myself. Now I've got another 7, so that doesn't fit into my bin number 1, so I'm going to have to open up a new bin, bin number 2, which also starts out with 10 capacity. This bin number 1 is down to 3, by the way. And that second 7 weight will go into bin number 2. Cross that out. Update my capacity is now 3. Now I've got a 6. That doesn't fit into bin number 1 or bin number 2, so that's going to have to go into a brand new bin, which I will creatively call bin number 3. That bin started out with 10 capacity, but now it's immediately down to 4 capacity, and I crossed the 6 off my list. Next, I've got a 5. Again, doesn't fit into any of the bins that I have now, so I'm going to open up a new bin, bin number 4, and put the 5 in there. That bin started out with 10 capacity, it's down to 5, and I cross out that 5 off my list. Now I've got another 5 that doesn't fit into bin number 1, doesn't fit into bin number 2, doesn't fit into bin number 3, but it does fit into bin number 4, so that's where that second 5 is going to go. Cross that off my list, update my capacity. Bin number 4 is now full, so nothing else can fit into bin number 4, so that's good. Remember, we're looking for these good fits. We like it when the bin fills up exactly. Okay, so now we've got a bunch of 4s. So the first 4 can fit into bin number 3, so I'll put it there. Cross that off my list, update my capacity. Bin number 3 is also perfectly full. The next 2 4s, though, neither of those can fit into bin number 1 or bin number 2. So when I hit that second 4, I'm talking about this 4 right here, That 4 is going to have to go into bin number 5, which starts out with 10 capacity, but then is down to 6. Cross that off my list. The third 4 on my list, that's this 4 right here, that can't fit into any bin except for bin number 5, so that's where it goes. And my updated capacity is 2, and I cross that 4 off my list. Now I've got a weight of 3. Again, my first fit algorithm says put it in the first bin it can fit into. Well, that's bin number 1. Bin number 1 is the first bin on my list, and then 3 can fit in there, so that's where it goes. Updated, my capacity is down to 0. Cross my 3 off my list. Finally, I've got a weight of 2. That's going to go into bin number 2 because that's the first bin on my list that can hold it, so that's where that 2 goes. Cross it off my list, update my capacity, I'm down to 1. So I was able to fit all of my weights into 5 bins, which if you compare this to the results that we got in the previous lecture is actually an improvement. So as we see, sorting the lists of weights from heaviest to smallest is actually giving us an improvement in our solution. Okay, so the best fit decreasing algorithm is a similar variation to the best fit algorithm. Again, as we said, first we're going to sort the objects in order from largest to smallest, and then work the way through that list one object at a time. We're going to put each object in the bin that will have the least amount of room left over. Remember, that's what we mean when we say best fit. That doesn't mean best solution. It means we're looking for the best fit for each object. And then, just like in the first fit algorithm, we only start a new bin if none of the existing bins have room for the object. Okay, so again, our first step is going to be sort the list, and this is going to be the same problem, so it's the same sorted list, which was 7, 7, 6, 5, 5, 4, 4, 4, 3, 2. So same sorted list as before, so don't go through that again. And now, as usual, we're going to start with one empty bin that has capacity 10. We've got a 7, that's going to go in bin number 1 because that's the only place it can go. Update my capacity down to 3. Cross 7 off my list. I've got another 7 that doesn't fit into bin number 1. That's bin number 1 is the only bin I have right now, so I have to open up a new empty bin with capacity 10, and that's where the 7 is going to go. Cross the 7 off my list, update my capacity. So for a while, this is going to look very similar to the solution that we did before because our list is sorted, and so for the biggest weights, we just keep having to open up new bins. We don't have any choices. So bin number 3, that's where the 6 is going to go. That started out with capacity 10, but it's now already down to 4. Cross the 6 off my list. 5, no room for that in any of the bins that I have, so I have to open up a new bin. That started out with capacity 10, and it's now down to 5. Okay, now we've got another 5. So again, the best fit algorithm says, of all the bins that weight can fit into, which one fits it the best? Well, there's only one bin that 5 can go into, so I don't have any choices. It's got to go into bin number 4. Update my capacity, cross the 5 off my list. Now I've got a 4, and again, there's only one bin that can hold that 4. That's bin number 3, so that's where it goes. Cross that off my list, update my capacity. I've got another 4. Well, that 4 can't go into any of the bins that I've got. It doesn't fit into bin number 1, doesn't fit into bin number 2, so it's got to go into a new bin, which I'll call bin number 5. That's where that 4 is going to go. And my capacity starts out at 10, but immediately goes down to 6. Cross the 4 off. I've got another 4. Again, there's only one place that can go. That's bin number 5, so that's where it goes. Update my capacity, cross that off. Now I've got a 3. Now I have a choice, right? So now I have a choice between where to put that 3. Should I put it into bin number 1 or bin number 2? But there's a tie, right? Neither one of those is a better fit than the other one, so typically we'll just put it in the first bin that we see that breaks that tie. So we'll cross that off, capacity down to 2. No, down to 0, sorry. So now we've got a 2. Now is the only place where this solution is actually going to be different from my first fit decreasing solution. Because now there's 2 bins that can hold that 2. The 2 can go here into bin number 2. It can go here into bin number 5. But it's a better fit to put it into bin number 5 because there's less room left over if I put that 2 into bin number 5. If I put the weight of 2 into bin number 2, then I'll have 1 space remaining. But if I put it into bin number 5, I'll have 0 spaces remaining. That's a better fit, so that's where the 2 goes. So the 2 goes there for my best fit, cross the 2 off my list, update my capacity. So I have a slightly different looking solution to my problem here. Get my eraser working. There we go. So this is my solution to my problem using my best fit decreasing algorithm. Okay, so next time we're going to talk about one more variation on this bin packing problem called scheduling problems, but we're going to use some similar ideas to what we've already talked about.